Okay, so last time we were doing two-way ANOVA. We started two-way ANOVA, chapter 13, and then I sent out over the weekend, or I guess it was Friday, your homework assignment, which is all over chapter 12. And there's an Excel part to that, and there's a SAS part to that, and then it's answer the questions out of the book. There will not be a separate Launchpad assignment out of chapter 12. I just didn't have the patience for it. So, any questions over the homework, one-way ANOVA stuff before we continue on with the two-way? No questions? Okay. So last time we started with the two-way ANOVA, and we were looking at this example with expressive writing versus control on first and second exam, and we talked about interaction. And remember the interaction plot. And what do we mean, first of all, by interaction between two factors? And this is statistical interaction. What does that mean?
Yeah, we were talking about that last time. I brought up the idea with my antihistamine and alcohol, and you said that would be a chemical reaction, not a statistical one. So what is the difference now? Because you were trying to say that the pharmacist sees this in a different way.
Right. A chemical interaction between two drugs is that, the alcohol makes it work differently, right, or whatever. That can manifest itself into a statistical interaction, but maybe not. You know, the two might be related, but there's no guarantee of that. By statistical interaction, we mean that the main effect, remember that's a new term, main effect. So you have main effects and you have interaction effects. So the main effect of one factor depends on what level of the other factor you're at. Okay? So in this example, well, first of all, does this example depict interaction or no interaction? Interaction. This is definitely interaction. No interaction looks like what? Parallel lines. Okay? So mathematicians, they're all over that parallel line stuff. But now what does that mean in terms of the effects? So if I draw this dotted line being parallel, so there was no interaction, then what am I looking at that depicts the main effect of group? This is, the solid line is control, the dotted line is expressive writing.
So expressive writing raised the mean by 3% or whatever it was?
Okay, the expressive writing raised the mean. That's the effect of writing, right? Of that factor, writing group. That expressive writing was about 3 units higher on both exams. So main effect is averaging across all exams, all tests. So averaging across all levels of the other factor. Right? But interaction, the effect changed. When they take the first exam, there's about a 3-unit difference. But when they took the second exam, there's a huge difference, about a 20-point difference from 70 up to 90. So the size of the effect of writing group changed at different levels of the other factor. That's statistical interaction. Okay? So we shelled out an ANOVA table for this, which I can probably figure out how to open. Chapter 13, day 1. So we did this last time. We fleshed out an ANOVA table. All right, so this is in general. And so for this particular example, we have writing group, call that A, and then tests, time, first test, second test, as B, and then interaction. So the test for interaction is the mean square for interaction divided by the mean square error. All the tests are mean square error. Right? All the tests have that as their denominator. So we would expect that that test, the F test for interaction, would be highly significant in that picture, right? So what I want to do today is get an example with some data in it and show you how to do it in Excel and how to do it in SAS, and then we'll use the output we get to interpret. The only problem is, the disclaimer for today is, I couldn't get SAS to run in my office. I can launch SAS, no problem. But the SAS Enterprise Guide, it would pop up a window that looked like it was going to load, and then I'd get an error message that said there was a problem with SAS. So you have two choices: close the program, or look for information on the web and close the program. If you close the program. Yep.
I did this on the homework, and I opened a ticket on this, and I actually copied and pasted the exception message.
Okay, I did too.
Good,
So,
yeah, but
we'll see.
I couldn't, and I haven't heard back from him yet, so.
Okay, so I haven't heard back yet either, but I only did it about an hour ago. So we'll go to Excel and do a data set out of a homework at the end of chapter 13. So I'll give you the scenario, and then we'll do the analysis. Oops, that's not where I want to be. I want to be in data sets. Data. Okay, so this one I've already worked, but when you load the data set, you have these columns of data. So you have to rearrange the data a little bit, just like we did with one-way ANOVA, to get it to work in Excel. So first, let's set the scenario for this data. This is actual data that was collected, and they were looking at mostly in third world countries that don't have access to supplements like we do here, iron content in the food. So they were looking at what is the iron content of 3 different types of food: meat, legumes. What are legumes? Beans, and vegetables. Right? So they're cooking 3 different types of food in 3 different types of pots: aluminum pots, clay pots, or iron pots. So I got how many factors in this study?
6.
Nope. What'd you say in the end? No.
Oh,
Trick question. What does the word factor mean? We have 2. There's 2 factors. Type of food, type of pot. Each of those factors has how many levels? 3. So then you have 9 combinations of levels, right? So basically 9 groups of subjects, only the subjects aren't people, they're batches of food that have been cooked. So they cook a batch of food, and then they do chemical tests on it to see how much iron is in that food. Okay? So the data is set up in columns. The first column says OBS, which just stands for observation. So this is observation number 1, 2, 3, and so on. We don't need that variable. And then pot is a categorical variable: aluminum, clay, iron, aluminum, clay, iron, aluminum, so on. Right? And then the next column says pot ID, and that's just a numeric variable. So aluminum is number 1, clay is number 2, and iron is number 3. So you don't need both, but some software won't allow categorical variables, and it needs numeric, and so that's why they offered that. But we won't need it. And then dish. The column dish says meat, legumes, or vegetables. And then it's the different combinations. So this first set of 4 observations is meat cooked in aluminum pots. Then the next 4 is meat cooked in clay pots. Yeah?
Is that the same kind of pot, the same
meat dish each time?
Yes. Same meat dish. They don't tell us what that is, whether it's beef or goat or what it is, but everything else is controlled to be the same. Right? And then finally, column F says iron, and so that's the dependent variable, the iron content of the food. So in order to run this in Excel, you have to rearrange the data to look like this. All right, so now can you see what happened? Let me turn on my being able to write on the screen, and then now that's in the way. So that's in the way.
Just, I think if you click the mouse arrow at the top,
Yeah. Then you should be able to
where you
close out
normally
of it.
select the pen.
Oh, this thing?
Yeah, now you can click exit out of it.
Ah, good. And then I go back to that.
Yep.
Thank you. Okay, so these first four observations, aluminum, pot, meat, 177, 236, 196, and so on, you see those numbers right here. So it's set up now in a grid that has, as the rows, the type of pot, and as the columns, the type of dish, right, or type of food. So column of meat. So if you look at this, 1.77 down to 4.22, that's all of those. So all I did was drag across that, copy, paste. And I wrote the word meat and legumes and vegetables. Right? So put that in, and then went from there down the next 12 observations down to 372 and pasted it here. And then go down, paste the next one until you got them all. Right? And then I just copied and pasted, but copied and pasted the word aluminum, the word clay, and the word iron. I added the grid lines just to make it pretty, but you don't need those. Right? But it made it easier to see the data. Okay?
So SAS will recognize that aluminum's for all four of those? Or, sorry, Excel will recognize?
Recognize what?
Like in the pot, you don't have to paste aluminum in every single one?
Right. I don't need to add the word aluminum each time. Because it's going to ask me, how many rows are there for aluminum? And I'm going to say, there's 4 rows. So then it's going to know. Right?
Okay.
Now, while that made me think of this, because I didn't know the answer to this question, so I experimented around. It's too much to remember with this. I experimented around. What happens if you have different sample sizes in each of these groups? Like over here, it's perfectly 4 each time, right? But what if you had 3 meats in aluminum and 4 beans in aluminum and 2 vegetables? It doesn't like it. You get an error message and it says each group must have the same number of rows. So Excel is not really flexible. So if you have unequal observations, and usually that happens not by design, but just by missing data, messy data. That, oh, one of the dishes got spilled before we could get it measured, so we lost that observation. Now Excel can't be used to run that data. You need to go to SAS. SAS doesn't care. SAS will run it. Okay? Get my circle the line back up. Thought I was. There. Okay? So then I've already run it once, so this is the output that came out of it. So let's repeat that and drop it over the top of this. But we will let you I think I can do it with this, right? So to analyze it, go to Data, Data Analysis, just like always. And then again, this picks random number generation as the one it highlights by default. So there's stuff above the top of this. So I'm going to scroll up. So the first one is ANOVA single factor, then ANOVA 2-factor with replication, ANOVA 2-factor without replication. what does that sound like is the difference? With replication, without replication? What do you think that refers to?
If you have something repeated.
Okay? And what about this data? Do I have with replication or without replication? With replication, right? What without replication means is that at every combination you only have one observation, right? So you have one meat dish cooked in aluminum, one bean dish cooked in aluminum, and so on, right? If you have only one observation per combination, an interesting thing happens with the ANOVA table. What would, let's go back to here. Can I not go back to there? I hate this. How do I open that again?
I think you gotta click that thing up there that you clicked to get it. Over there on the other side.
I don't know what you're pointing
The thing that you did to get it to write on the screen, undo that.
at. Hey, thank you. Gotcha. This is what I want. Back to this. What happens if there's no replication? Then you've got 3 levels of A, 3 levels of B, and what's your N?
Yep.
Your total number of observations. 9, right? 3 dishes, 3 types of pots, and 1 per each. You got 9 observations. So N minus 1 is going to be 8. What's I minus 1 going to be? 2. 2 and 2 and 8. Right? So what does interaction work out to be? 4. 2 plus 2 plus 4 is 8. What's left over for error? 0. You can't run an analysis with 0 degrees of freedom for error. So what happens then is, the way a statistician would say it, is the interaction term is confounded with your error term. It is your error term, right? So you can't test for interaction if you don't have any replications, because you don't get any within group variability. Error is within group variance, right? Then these sources are between group variances. And the whole idea of analysis of variance is trying to separate that out. How much of the variability is due to groups or factors? How much is due to random noise within groups? Right? Just random fluctuation. Well, if you only get one observation within a group, you can't estimate that. You have nothing left for error. So the error becomes the interaction term, and you can't test for interaction in a model way. So that's what Excel does. It asks you that question so that it knows, oh, am I going to use an interaction term or not? It does not let you decide to include it or not. If you say with replication, it includes it. There's no way to tell it not to. In SAS, you can choose whatever fact. You can say, well, I know there's not going to be an interaction, or maybe I've already tested it, so now I want to remove it because it's not significant. SAS will let you do that. Excel will not. You either have it if you have replication, or you don't if you don't have replication.
So, but if you choose the no replication, you still can't run the same 4 lines or whatever because, right? Because it's going to assume you just have 1 row.
Exactly. It doesn't then ask you the question of how many lines. It just says, oh, it's 1, and then it gets all confused. Okay, so with replication for this example. And first thing, it pops up this little window and it says input range. So the input range is this box of data. And you want to drag across the words also. If you don't have to, but if you don't, it'll say row 1, row 2, row 3, column 1, column 2, column 3. And then you got to figure out, oh, that's the legumes, and that's the aluminum or whatever. So input range we're going to drag across, let's see.
I think you have to maybe click it first and then drag it.
Yeah, I'm just going to use the mouse. This is turned to the wrong thing and I can't figure it out. So click in there and drag. Okay, so I drug across I5 to L17. So this is column L and row 17. That's down here. Got it? And then it says rows per sample. And that's 4. And then alpha 0.05, what is that asking? Significance level. Do you want to use 0.05? Almost always the answer would be yes. So then output options, the default is to put it in a new worksheet. So it'll create a new worksheet down here and drop the ANOVA output into that, which is fine. I had dropped it here before, so I'll just put it here again over the top. When I click that, again the cursor jumps up there, so you don't want to mess that up. So go back into there, and then I'm going to use the mouse and click that cell for where it should start. You don't have to get the whole range, just where it's going to start. Okay? And then just say OK. And this is warning me that, hey, there's stuff in those cells you're going to overwrite. And that's fine. But for you, that won't be there. So there's what it did. So let me scroll up. And I'll turn off that shading. First thing it does is give me a summary of the data. So it has a block for aluminum, a block for clay, iron, and total. So looking at aluminum, it says count. Meat, I had 4. Legumes, I had 4. Veggies, 4. And total, 12. And then it has sum, average, and variance. Right? So I don't care about the sum, but let's look at average. This number, 2.0575, represents what?
There was 2.05 units of iron in aluminum meat.
Good. In aluminum meat. So the mean of the 4 observations that were meat cooked in aluminum had 2.0575 units of iron. And then when I go to legumes, it went up to 2.33. Vegetables down to 1.23. Then out here is 1.87. What is that number?
Average for everything cooked in aluminum.
The average across all types of food, everything cooked in aluminum. Right? So this is called a marginal mean. So it's giving me the cell means, and then the marginal means, and then down here at the bottom where it says total are the marginal means for the different types of food. So each of those has 12 observations also. Okay? So now, just looking at numbers, predict what the ANOVA table is going to show.
Iron significantly.
Do you see a main effect of type of pot?
Iron?
Yes.
Okay, what do you notice?
If you cook it in iron, you have more iron.
If you cook it in an iron pot, you get 3.7 units. If you cook it in either of the other two, it's substantially lower. How does aluminum compare to clay?
Not much lower.
It's not much lower, but it's a little lower, 1.87 versus 2.04. But look at the amount of variability. Well, that's variance, not standard deviation, so it's hard to tell. But that may be within what we would call random chance. Probably is. But this one looks to be substantially higher. Yeah.
Clay is porous. It has minerals in it. I wonder over the life of the clay pot if after a while it basically leaches all the iron out of it so it will stop having that effect.
Yeah, I don't know.
But I know for a fact clay is porous and it affects the stuff that you cook in it.
Yeah, and cast iron is porous as well.
Yep.
But iron is obviously putting some iron into the
Yeah,
food.
it would make sense.
Because vegetables typically don't have much iron. But they do if you cook them in an iron pot. So now, main effect of type of food.
I don't think you're going to see.
Legumes.
Again, main effect, you want to look at marginal mean. So we have an average of 2.97 for meat, 2.82 for legumes, and 1.8 for vegetables. So both meat and legumes seem to be fairly high in iron on average, whereas vegetables are quite a bit lower. Okay, now the $40 question. Is there interaction?
Let's test for
I want you to do the eyeball test before you test for it. You're p-value happy, aren't you? What do you think?
it. Yes.
Okay, tell me why you say yes. What do you notice?
I see that the iron content definitely goes up when you cook with meat and also with cast iron, so I think you'll see a difference there.
Okay, think about a means plot. Can I, probably can't draw on that right now, but if I go to here, and go to here,
Make sure you're on the mouse. Oh, you are drawing.
I think I'm good. Can we sketch an interaction plot? An interaction plot will have 9 points in it, and so we pick one of the two main factors, main effects, to be the x-axis. So let's pick type of vegetable. So we've got M for meat, L for legumes, and V for vegetables. And then I'm going to put a dot for each type of pot. So in aluminum, I'm at 2.05. So if I go, let's see, what's the biggest number I got in this whole thing?
Iron, 4.4.
4.6. I got to go to 5. So if that's 1, 2, 3, 4, 5. Right? So 2.05 for aluminum. That's about right there. And 2.17 for clay. It's about right there. And for iron is 4.68. And then go to legumes, and we go 2.33, 2.47, and 3.67. So 2.33 is about right there. I'm not being very accurate, obviously, but, and then 2.47 is just a little bit above that. I should be using a different symbol, but you can keep track for me, right? And then iron is
3.67.
3.67. So 3.67 would be 2/3 of the way up there, about right there. And then veggies, we've got 1.2, so that's down here. And then about 1.5, so about right there. And then iron is 2.8. So 2.8, about right there. All right, now I'm going to connect with lines. I bet I can change colors. Act like I know what I'm doing. The bottom set of points all came from the same one, right? So that was aluminum. Yeah, so the aluminums are always lower than the other two. So this one in blue is aluminum. All right, and then the next one is clay. Do you see interaction there? No interaction. They're pretty parallel. Right? But then for meat, what happens?
There's partial interaction. Or like the first part.
That's probably not going to show up, is it? Can you see that? Let's just do a nice dark one. So there's meat.
Iron, it's iron.
So when you cook meat in an iron pot, you really get an explosion of iron, right? You get more iron for any type of food, but something about meat in an iron pot really makes, the meat must really extract more iron from the pot, right? So that's interaction. The effect of pot depends on what type of food you cook. If you cook meat, then you get a huge bump in iron, whereas if you cook the other two, you get a modest bump in iron. Okay?
So there would be an interaction with meat, but not for legumes or vegetables.
No, and I heard somebody else say that. And I heard somebody say partial interaction, right? And it doesn't work that way. There's either interaction or there's not. So you could say between aluminum and clay, there's no interaction. And that's okay to say. But between, you can do it pairwise. But the test we do for interaction is just, is there any interaction or not? There's no partial to it. Okay? So now let's scroll down and look at the output and see if we can stop doing that. I went too far. Did I go too far?
There's the.
So there's the ANOVA table, and boy, I hate to get rid of that plot. Maybe I can scroll this. Yeah, there we go. Okay, so here is the ANOVA table. Is that big enough to see? I wasn't asking you, I was asking the video. And I think the answer was no. So, install another. Yeah, that's better. So here's the ANOVA table. Source of variance. Oh. What happened to the words? Aluminum and... Because it was using them up here. Iron. I don't know. I thought it would use it down here. Well, I guess it would have. It can only use one word, so it can't use aluminum. But, so you just have to know that the word sample that Excel puts on there, the blocks by rows are the samples. The columns, it uses the word columns. So samples is one factor, columns is the other factor. Look at the degrees of freedom, 2, 2, and 4. Interaction is always the product of the two main effects. Then there are 35 total degrees of freedom because there are how many observations? 6, or 9 times 4. There were 9 combinations, each had 4 observations. So 9 times 4 was 36 total numbers in the data. So 35 degrees of freedom. And then 2, 2, and 4 subtracted from 35 leaves you with 27 degrees of freedom for error. Okay? But you could also get that by 36 minus I times j. So 36 minus 9. Now look at the sums of squares. Sums of squares in an ANOVA table don't really mean a whole lot to us. It's mean squares that are more important. The mean square for within, what does that mean? That's not the words I used earlier. Excel uses within. No?
That's error.
That's error. So Excel says within, and that I'm fine with that terminology because that's what it is. Within a combination of factors. A type of food in a certain type of pot, the within group variability is now those 4 observations, how much variability was there between them? And that's what that's measured. So the other 3 are between group, that's within group. And it's pretty small. When you do mean square, you divide by degrees of freedom, and you get 0.13 mean squared error. And for sample, which was pot, type of pot, you get 12.44 for the mean square, divide by the mean squared error, and you get 92.26. And I don't know that much about F critical values, but that's a big number. So guess what the p-value is? Really small. 8.53 times 10 to the negative 13th power. So there's a huge effect due to type of pot. So basically, is there a separation between these lines? That's what you're testing. And clearly there is. Now, 4 observations per group is not a lot, but the variability between them was really small. Right? So within group variability is pretty small. So you can easily detect that much difference. But had these numbers been much more variable, so these variances were big, then 4 wouldn't be enough. It wouldn't be significant, even though your picture might look the same. If you put the dots around it, if the dots are really spread out and overlap with other groups, then you're not going to be significant. But here, with this data, we've apparently got dots that are real close, so there's no overlap. So very clear separation. So then, columns is the type of food, and that is also highly significant. 3.7 times 10 to the minus 8. So there's a very big difference in foods in their iron content, even when cooked in the same type of pot. So remember, it's just like regression. When you look at the main effects, it's averaging across all the others. Or you can also think of it as holding the others fixed. Right? So even if you cook in the same type pot, there's a big difference in iron content of the food types. Meat has the most iron in it. Then legumes, then vegetables. Okay? I thought it was kind of interesting that unless you're cooking in iron, beans have more iron than meat does. So I always thought, when I grew up, if you need some iron, eat a steak. Get some meat in you. But it's actually beans have a little more iron. Okay? And then interaction. The p-value for interaction is 0.004. So what's the conclusion? Reject the null. Okay, now you're going to make me remember what the null is. What's the null? In words, it's pretty easy.
The null is
There's no interaction, right? So the effect of pot on iron is the same, this is the null, is the same for all levels or all types of food. The alternative is the effect of pot changes for different foods. So we reject the null and conclude what I just said. The effect of pot depends on what food you cook in, or what food you cook in it. Okay? So the homework problems over this will then ask you a lot of questions that are going to be hard to answer with Excel. SAS does it really easily, but I can't get to show you. But when you run a two-way ANOVA, it will automatically give you plots, residual plots, so you can look at whether the residuals are normally distributed. You'll get both just residual plots with the dots on them, but you also get those normal probability plots. We've talked about those, right? We did it when we did regression. Sometimes called a PP plot or a QQ plot. Did we not talk about that?
Hey, yeah, because
I know I did in regression class, but
no, because you said they produces all these graphs and you're able to look at them and see. I don't know if we went into what they're really saying.
Because I knew I couldn't get to SAS, took some of the output and put it into a PowerPoint presentation.
You gotta
You gotta
make
go out
sure.
of the desktop landscape.
That. Okay. Someday I'm gonna get this all figured out. But not soon enough to help you guys. Okay, so here is the same analysis done in SAS, but I have this on my own personal PC in a ditch, so I didn't have to. I could do it even though the WooStat server wasn't working, but for now at least you won't be able to get to that. I lost my page browser. View and browsers. There. Right? So in SAS, this is the Excel spreadsheet read into SAS, so that's no big deal. Everybody remember how to do that. I'll post this out there on D2L. It looks like when it imported into here, it made the picture bigger and covered up my words, but open data in SAS Enterprise, and then you're going to go to tasks, and then ANOVA, and then linear models. I think I mentioned that last time, that it has one-way ANOVA, and then it just says linear models. It doesn't have two-way ANOVA. Right, so if it's not a one-way ANOVA, you need to go hit linear models. And that's the one that allows it to not worry about if you have the same number of rows for each group. A general linear model will work fine. Okay. So then when you do that, this window pops up. And in the left panel, just like when you were doing regression, you get the left panel that kind of says, okay, how do you want to set it up? And then you have panels for your variables. So when you first click on data, I thought I made a slide for that. Maybe I didn't. Apparently not. When you first click on data, it'll give you the list of all your variables. And then it gives you a panel over here that says dependent variable, classification variables, quantitative variables, and then by groups and things like that. Right? So if you have categorical factors, like both of these are categorical, type of dish, type of pot, then we put them in as what we call classification variables. They just classify the groups. Right? Analysis of covariance, which we're going to do as soon as we finish this chapter, then that will add the possibility to put in quantitative variables into the model as well. Right? So an analysis of covariance lets you put in a second dependent or another independent variable that isn't categorical. So it might be I don't know, something like the weight of the food. So you're cooking in this type of pot, this type of food, but how much are you cooking? Something like that. So for now, put everything in as a classification, and it'll say / qualitative variable. Okay. So you put that in, and then it took me the longest time to figure out how to do it. I wanted it, these buttons were grayed out, cross and factorial. And they were grayed out and I couldn't click them. That's what gives you this interaction term. So this is small, so you may not be able to read it, but it says dish, pot, dish, star, pot. So that's your interaction. And to get it, you have to highlight both of these. So you click, hold the control button down, click the other one, so they're both highlighted. And then these ungray, and you can click them. So cross means cross product, so multiply them. That works. Or if you just click factorial, then it would default and do, if you have like 5 of these variables, it would do all the two-way interactions with one click instead of having to highlight them and say cross. Then highlight 2 more, say cross. You can just highlight all 5 and say factorial, do them all.
So you can just always select factorial then?
Yeah. We won't do more than 2-way, even though this is general. You can have 5-way or whatever. But once you get to once you get to 3 variables, interaction gets really tough. A 3-way interaction is really hard to explain to a non-statistician. If it's significant, it's like, well, the 2-way interaction changes when you go to different levels of the 3rd variable. And it's hard to explain. And we won't do it in this class. But then after you click factorial or cross and you get the interaction term in there you want, you can then click on, let's see, model options. I don't think that did anything for me. Where am I at here? Yeah, I just clicked run at that point. Right? You can ask for means comparisons and things like that. I didn't do it here, but that's one of those options, means comparisons. So here's the output that we got. And recognize that some of these p-values and f statistics are exactly what we had in Excel. So we had the 92.26 for an f value for pot. It reversed the order of addition pot because that's just the order I had them in. But and then interaction 4.89 with a p-value of 0.0042. So all that's identical. It doesn't give me that nice breakdown of marginal means and within group means that we had before. You can get it easy enough, but it's not default, won't give it to you. So you just do some summary statistics by those variables and it'll give you all that. And then, let's see. There's something else on here I wanted to, this overall F statistic. I forgot to talk about it. It was also in the Excel output, but I forgot to mention it. What is that testing? It's got a p-value, so it's testing something.
Their food or pot doesn't make a difference if they're in the iron levels.
Yeah.
It's testing the whole model.
So food or pot, neither one make any difference, right? So you can think of it as like a null hypothesis with mu ij. So mu 1, 1. Pot number 1, food number 1 is equal to pot number 1, food number 2 is equal to ... down to all 9 of those. They're all equal. Versus the alternative that at least one of them is different. So that's the overall test for the model. The way I like to say it is the model, all of the factors in the model, pot, dish, and interaction, don't help explain variability in iron content. Versus the alternative that it does. At least one of those factors helps explain iron content. So highly significant. We knew it would be highly significant because individually these were all highly significant. So then finally, these are the residual plots that you get out. Here's a histogram of residuals. Looks pretty normal, so looks good. Regular residual plots, residual by predicted value. You could do a separate residual plot for each level of like pot or whatever. And then these are the normal probability plots I was talking about, the PP and QQ plots. So I'm out of time. I'll talk about that next time. So
Is that, I know we didn't go over it in here with regression, but normally we went to more regression.